Let us take a look at question 15. Well, question 15 says, solve the following. Y dx minus 4 times x plus y to the 6th dy equal to 0. Y equal to 0. So let's follow the steps. Step 1, which classification this guy belongs to? Well, is it separable? Is it linear? And step 2, apply the method related to either of these. Apply the method. Well, okay. So can we write this in separable form? Take a look at this term here. You have x plus y to the 6th. They're connected together by addition. So there is no way you can separate these. So what we're going to do, we're going to check to see if it's linear or not. So separable, that's not separable. So what's the definition of a linear? Let us check to see. Let us check if it is linear. This is our goal. So remember that when you have a definition of a linear first order ODE, you have a sub 1 x y prime plus a sub 0 x y equals to g of x. So we need to reorder this. First of all, you have dx, you have dy. First, do the division and divide everything by dx. So let's just do some algebra here before going over step 1 and step 2 and following that. So here you have y minus 4 x plus y to the 6th dy over dx equal to 0. So if you take a look at this, you have negative 4x plus y to the 6th y prime plus y equal to 0. Okay, so what do we have here? It says, hey, a sub 1 of x is the coefficient of y prime. What is the coefficient of y prime here? The coefficient of y prime is negative 4 times x plus y to the 6th. You have a term which is a combination of x and y. Here you have y to the power 6. So can we decide if it follows the linear definition? Does it satisfy this pattern? It seems like if we write it in terms of y, then it's not linear. So should I stop? Now try to apply the different definition of a linear ODE. So it's not linear if you have y equals to f of x. It's not. But what if I write x in terms of y? What if I write x as a function of y? What happens here? So we have to analyze everything. Let's do the algebra. So our goal is to try to write it as a1 y x prime, let's see, plus a sub 0 y times x equals to function of y. Let's see. So if we divide everything by dy to the algebra, what do you get? Divide by dy instead of dx. What do we get? We get y dx over dy minus 4 times x plus y to the 6th dy over dy equal to 0. Let's see what's happening here. So here you have y x prime minus 4x minus 4y to the 6th equal to 0, or yx prime minus 4x equals to 4y to the power 6. Compare these two now. Here you need a term, a coefficient in y, multiplied by the derivative of x. As you can see, here you have y times x prime. So far, so good. Here you have term in terms of y multiplied by x. Here you have plus negative 4. Negative 4 is the coefficient here, plus minus 4 times x. So as you can see, here you have a coefficient which is just negative 4, and it is your a sub 0 y. And on the right hand side, you have a function in y, which is 4y to the power 6. Very good. So as you can see, if your x is written in terms of y, it means that if x is a function of y, then this guy is linear. Very good. So it is linear if x is in terms of y. So let's apply the method. Follow the steps. So it is linear. Step 1, write it in standard form. Write it in standard form. Very good. In standard form, let's just number this guy. 1. In standard form, we have to divide everything by the leading coefficient. The leading coefficient is y. So what do we get? We get x prime plus negative 4 divided by y times x equals to 4. Y to the 6th divided by y is y to the 5th. So this is our standard form. In step 2, find the integrating factor. So remember that if y is equal to f of x, then our integrating factor is e to integral px dx. Now you have function x in terms of y, your integrating factor becomes e to integral py dy, which is this term here. Okay, let's calculate the integrating factor. It's equal to e to integral negative 4 over y dy, which is equal to e to negative 4 ln of absolute value of y, which is e to ln of absolute value of y to the power negative 4, or 1 over y to the 4th. This is our integrating factor. After finding the integrating factor, we have to multiply every term by the integrating factor. 3. Multiply everything by 1 over y to the 4th. Okay, so far we're good. We found 2 as well, which is 1 over y to the 4th. Now, step 3, multiply everything by the integrating factor. So it was not linear if you write it this way. So here you get x prime divided by y to the 4th plus negative 4 over y to the 5th times x equals to 4y. So now in step 4, you're going to see the expanded form of the product rule. What are you going to see? You're going to see the dy of x times the integrating factor. And on the right-hand side, you have the product here. You just get a new function. Let's just write it as q sub 2 of, here we have y. Okay, so take a look at your left-hand side. It is y to negative 4 x prime plus negative 4 y to power negative 5 x equals to 4y. Here you have the product rule. It is written as the dy of x times integrating factor, which is y to negative 4. And on the right-hand side, you keep whatever is on the right-hand side. Now, in the last step, step 5, well, we need to take the integral of both sides. Okay, if you take the integral, this is step 4 and step 5. The integral and derivative, they're opposite operation. They cancel out each other. So you're left with x, y to -4 equals to the integral of 4y dy. So x, y to -4 is equal to 2y squared plus constant of integration like c. So your x is equal to 2y to the second divided by. Okay, here we are multiplying. Let me just, I don't want to use the negative exponent. So you get y to the 6 plus c, y to the 4. This is the general solution of this differential equation. So as you can see, your x is isolated on one side and you're explicitly defining the general solution here.